All right, let's take a look at a position time graph. This was on the last problem set, and so I want to use this graph to set up the next thing that we're going to look at. So position versus time graphs, the slope, as we've previously discussed, slope is equal to the velocity of the object being described by the graph. So if we find the slope of this line, that tells us how fast the object is moving. The slope of this line and the slope of this line, each slope of each line segment tells us how fast the object is going. Now, the way I have this set up, we have 4 line segments, so we can find 4 different slopes. So let's label these A, B, C, and D. So for A, we're going to have a displacement of 6, so it goes from 2 to 8. Remember, slope is y2 minus y1 over x2 minus x1, and in this case, the y's are the positions and the x's are the times. So the slope at A is going to be 8 minus 2 over 2 minus 0. That's going to be 4. And because we have our y variable divided by our x variable, we're going to have also meters divided by seconds. And we can do the same thing for B. I should make a colon there. So B, that will be 8 minus 8, because now we have a horizontal line over 4 minus 2, and that will be 0. For C, we're going to go down to a negative 2, and remember, this is always final minus original, 2 minus 8 over 6 minus 4. So that will be a negative 10. Remember, this minus sign is simply part of the equation. That minus sign is due to the position of the object at that point. So minus 10 over 2 is going to be a minus 5 meters per second. And then for part D, going to end up back at 0. Was at negative 2. Remember, the minus sign is part of the equation. That minus sign is from the position of the object. And then 8 minus 6. So then that will be 1 meter per second. Now, each of these things can be turned into its own y-coordinate on its own graph if we change our vertical axis. So we were graphing where is the object and when is it there. We could graph how fast is the object going and when is it going at that speed. So what we could say is, hey, let's take all these velocities and graph all those velocities versus the time that those velocities occurred. So for the first 2 seconds, our object is moving at a speed of 4 meters per second. So let's see here. Let's 2, 4, 2, 4, negative 2, negative 4. So for the first 2 seconds, our object is moving at, wait, what? No, 8 minus 2 is 6 today. 6 divided by 2 is 3. There we go. Something just felt a little bit wrong there. So 8 minus 2 is 6. 6 divided by 2 is 3. So we're going to be up here at 3 for the first 2 seconds. And it's a constant 3 meters per second for the first 2 seconds. Because the slope of the line does not change during that time, the velocity of the line does not change during that time, because now the vertical axis tells us about velocity. And if the velocity were changing, it would be some kind of diagonal. For this one, the slope is 0. Since the slope is 0, that means that the velocity is 0. So when we come down here, we're going to use this guy. So up here we were talking about slope, and then down here we're going to talk about velocity. So down here, the velocity is 0 for those 2 seconds. For these 2 seconds, goes through a displacement of negative 10 in 2 seconds, so the velocity is a negative 5. So we're actually going to have to come down here, minus 6. And so minus 5 is going to be here for this guy. So there we go. For these 2 seconds, the slope is a minus 5, which means that for those 2 seconds, the velocity is a minus 5. And then for this one, we have a slope of 1. Did I get that right? 0 minus a negative 2. Ended up at 0 minus a negative 2. Good. For 2 seconds. All right. 1 meter per second. So for these 2 seconds, Since the slope is 1, that means the velocity is 1. The slope on this graph tells us about the y-coordinate on that graph. So slope here, slope, y-coordinate. Let's see if I can learn how to spell that, shall I? C-O-O-R-dinate. Notice that we have a pointy thing here. The slope suddenly goes from 3 to 0. This is a sudden jump. That's pointy. It doesn't happen in real life. And for my walk the line demo where I'm walking back and forth, you could see that we had pointy lines for the green. And then as I was trying to walk it and my red line was going on there, there was always a little bit of a curve there because I can't make my body suddenly change speed in that way. So what we have, because this is pointy, we're going to have a sudden change in speed. Because it's pointy, it's going to be a sudden change in speed. That doesn't really happen in real life very much. This is, again, just an exercise on a graph to make the analysis a little bit easier. All right, so the next thing that you're going to do is you're going to look at several graphs, not as many line segments as this one. We're going to have fewer things going on. We're just going to zoom in on 1 or 2 at a time. And what you're going to do is you're going to take the slope of this graph and turn it into its own graph on the next graph over in the corresponding space.